ExpertFunda. So today we are solving a super popular interview questions from the Leetcode, and this is problem number 160, and we are watching on YouTube, and I have created a separate channel, you can say playlist for the FANG interview, right? So I have created a separate playlist for the FANG preparation in 180 days, and in which I am talking about super popular questions, and that will build you the concept, and you can work on more questions on the, let's suppose, for the linked list and other type of questions, right? That is important for you. So this is the intersection of two linked list, right? And we will be solving it using a clean and efficient strategy that is called length alignment approach. So let's break it down step by step and make it a super simple. A and heads B of two singly linked list, as you can see here, right? And we have to return the node at which the two lists intersect. If the two linked list have no intersection, we will return null, right? Means we are given the heads of two linked list, and what is our job? Our job is to return the node where the two list intersect. As you can see in this graph, right? C1 is the node where we have to return it, right? So this intersection is happening only with the reference and not by the value. Okay, so if there is no intersection, we'll return null. If this is happening, we'll return the you can say node. Okay, so the linked list are, these linked list are, you can say, acyclic, as you can see here, and we are not allowed to modify them, right? So we have given the other statements, so you can pause it and you can go through it. Okay, so very simple, very efficient problem is this, and very popular for the interview perspective. So let's continue. A couple of examples we have given here, so we'll go through this example that we have given here, right? So we have given list A that contains what? 4, 1, 8, 4 and 5, right? And another we have given list is like this, right? 5, 6, 1, 8, 4, 4 and 5, right? These two we have given, means this is list A and this is list B, and we have shared nodes starting from 8, right? So if you not consider this part, right, so you can say the first node we have first list we have given 4, 1, 8, 4, 5, right? Another we have given 5, 6, 1, 8, 4 and 5. So this is called shared one, right? So this node is shared node, and that start from the value 8. Okay, so 8, 4 and 5 are shared node for both the list. It means we have to return the intersection point from where the sharing starts, right? Sharing nodes start, means the 8 we started, right? So take a look here, both list intersect at you can say this node with the value 8, right? This node with the value 8, right? But the trick is, it's not just the value, it's the actual node reference in the student get confused in the interview room, right? Maybe you will not get confused, but most of the student get confused that we have given this list, right? And this list contains value 1 at here. Similarly, there is another list we have given where the value contains 1 here. So here we have 1 and here we have 1, right? So why it is not intersect at this position and it intersect as 8, right? Why? So you will have to visualize yourself. This picture will not be given in the interview, right? You should understand that we are talking about the actual node reference, right? We are not talking about the value, right? This is the trick. Understood? This is the trick, that it's not just the value, it's the actual node reference in the memory, right? If the value is there, we don't care. We need to understand about the reference, right? And that is why the intersect node value is 8 here. This can be anything, right? This can be anything. Okay, so even through both lists contain the value 1, right? It doesn't intersect at that point, right? They point to the different nodes. These nodes and these nodes are different. They intersect at 8. Okay, I hope you understands. Let's continue, right? So the intersection of two linked list, it means we have given two singly linked list, like we have given head A and head B for the two linked list, right? And we have to return where they intersect by reference, not by the value. They intersect by reference, not by the value, and this reference is the actual node reference, right? So we don't care the value, we care the reference, okay? Because both can contain the same value, right? But the nodes can be different, right? Understood? If no intersection happens, we'll return null. If it is happening, we'll return the node. Okay. What are the constant? Constant saying that list do not contain cycle, and the linked list must retain their original structure after the function returns. But I'll suggest that you should go through the problem statements completely till the constant we have given, and then you should watch this video, right? So you will understand what I'm trying to say in this example, right? Okay, so let's understand. So there is also a custom judge for the test setup. You can go through the statement it was given, where we have given intersect val, means the value at intersection node 0 if no intersection happens. List A and list B, we have given the values in the list, and there is also another points we have given skip A, skip B, that is the number of nodes to skip in A and B to reach the intersection. And so we'll have a note that nodes with the same value are not necessarily the same node, right? The intersection means same memory reference, not the actual value. We have to keep in mind these things, okay? Now understand this example. We have given this example intersect val to list A, list B, then we have to skip A and skip B we have given, and then we will reach to the intersected at 2. How? If you represent the list A that we have given, right? 1 9 1 2 4 1 9 1 2 4, this is the list A we have given. Then we have given list B 3 2 4, so you can say 3 2 and 4. So list A, this is list A and this is list B, right? And both intersect at 2, right? And so the intersect point or intersect node is 2. Okay, so how this will work, that will understand. Okay, now the approach to solve the intersection of two linked list are many ways we can do the implementation, right? But the best way to write the code in the interview, right, is length alignment approach and two pointer approach. So it is very optimal approach to write the code. Apart from this, the two pointer is the best approach to write the code in the interview. Okay, and then we also have another approach, hash set and brute force, right? But the brute force is not recommended because it will take it will traverse for all the nodes, right? For a list A and list B, and that will become the time complexity O of n into m, right? And which is not recommended. But hash set we can use. This is faster than the brute force, but the problem is that it is using extra memory to store the nodes, right? So that is also not recommended. So either you go with the length alignment or the two pointer approach, but you should also aware with how to do in the hash set and the brute force approach. We are focusing on the length alignment approach. Why? Because it runs in O of n plus m with the time of n plus m, right? Time with O of 1 space complexity, and it's really a clean code and the very intuitive, right? So let's walk through the steps to implement. That is called length alignment approach. So these are the steps that we are going to follow in this example, right? So as we know, we have given the list node we have given, and the list node, each node contains a node, and that node contains the value and the reference of the next node, right? And there is a constructor that contains the value. It will pass the value, it will set the value, but it will also initialize the next node as a null. It will implies for the each node, right? So let's understand the each step and understood. So first of all, we have to get the length of both the linked list, and for that what we need to do, we'll write int length and we'll say length of a, right? Why? Because we have given two nodes, we have given heads, we have given list A heads and list B heads, and we call it as a head A, head B, right? So from head A and head B, we'll find the length with the help of helper function. So we'll call it a get length a function we'll call, and we'll pass the head, right? So we will create this function. How we are going to create this function? Okay, so let's suppose I'll create a helper method that is private get length, and it will return some length, right? So we can say it is a integer, right? Because this is an integer, so it will hold the data integer, so we'll return integer. And here we'll pass the list node, right? Let's suppose I'll pass this list node. So this is a generic method, right? So I'll take a head directly, or you can say node also, right? And we have to find the you can say length, and we'll return the length. So by default I'm passing 0 here, but if we are going to implement it, let's suppose we give a, let's suppose length like this, and we'll initialize from the 0, and then we'll return the length, right? Now we have to find the length, right? So let's suppose if this node is not null, right? Initially we have to check while this node is not null, like this. If this node is not null, right? If this node is not null, what we need to do? We will first define the length should be a plus plus, will increase the length, right? And then what we need to do? Then we'll move to the next node, right? From, let's suppose node is like, how node is there? Node is like A, B and C, right? Like this. So if this is a node, right? This node is the head node, right? Head means it is at here. So when it is here, I have initialized the length is 1 if it is not null. If it is not null, means there is some node is there, right? Some value is there at here. So that value increases the length 1. Now what I will do, we'll check next we have or not, right? So how we are going to find the next? To get the next node, you will just need to do node equal to node dot next, right? As you can see, we have two things in the node. List node is a type of list node, right? And it contains two attributes, the val and the list node next. So this next we will call, so we'll get the node, right? And this is also node, right? So we'll get the node here. So until it will reach to here, right? When it will reach to here, there will be another next is there. Why? Because see, we are passing this one and we are setting as a null, right? So when we are setting is a null, it means the next is null, right? If next is null, it means it is like this, right? The next is null means like this. This node is like this, right? It means there is null value, or we can represent this like how? We can write like this, means null. It means when it is null, it will break here. Next time it will not go here, right? So when the first node came, it become length 1. Second time came 2, then 3. Next time it will go null, so it will not go inside. So length will be remain 3, and so we are returning the length. Understood? This is very simple method. Okay. So this is a helper method that will help you to get the length. Then we'll calculate another length, and that is called B, right? So this is for head B, right? So we'll write for the head B. Now in step 2, what we need to do? We have to align the length, we have to align the starting point, you can say, right? How? Let's suppose if you have both length A and length B we have, right? So what I want to do, I will check the length while length A is greater than length B. Let's suppose if length A is greater than length B, right? It means the first node, list, the first list is greater than the second list, right? It means the length should be, the starting point should be what? It should be from the we have to move this, right? Until this is the length is bigger, right? Until the length is bigger, we have to position the starting point. And to position the starting point, what we need to do, we have to write head equal to head A dot next. We have to keep moving until the length is bigger. Until the length is bigger, right? How we are calculating this length? With the help of the head, right? So we'll increase the head, we'll move the head ahead, right? And we'll similarly will decrease the length. So we will also decrease the length until it will reach to the next. We'll keep decreasing it. How? Minus minus. You understood? Let's suppose there was an example, right? Give me 1 second, guys. Okay, come to here. Okay, now think about this example, right? So initially, which length is bigger one, B or A? The B was bigger one, right? This length is 5, right? This length is 5, but this length is how many? 6, right? 3 and 3, 6, right? So this is bigger one. It means we have to create for another one also, right? Let me write first, then I will explain you again. Okay, so let's suppose this is called what? B, and it is greater than what? A. In this case, head B will keep moving ahead and will decrease B. Now understand. Just think that it start from where? Here, right? And it start from here. The heads we have given, A is here and heads B we have given at here, right? Means 4 and 5. Understood? Now the length, if you calculate for the list A, it's coming 5, right? 5 is greater than 4? No. So it will not go here. In this loop, it will not go. Where it will go? It will go to this loop because 6 is greater than 5, right? We can do that. Now head B is at what point? At 5, right? So what we will do, we'll do head B dot next. Means we are moving from 5 to 6. Means we are moving. Now head is not at here. Where? At 5. Now it is at node 6. This one. Node with a 6 value. Don't say that node 6, right? Just say node with a 6 value, right? So from the first node, it will move to the second node, right? Till it will reach here, it will move, right? But you can see the length is now equal. It is not greater. When from 5 to, when the node with a 5, it will come to the 6. Means the head is now at 6. When it comes to the 6, both are equal. Means this loop is also not increased. Why? Because we have decreased the length. When we have moved from 5 to 6, we have also decreased the length, right? Means now both length is 5 and 5. So both will not continue now. Means first we need to align the starting point. Means starting point will be at 4 and 6 now. Means now it is not at 5, right? Understood, right? So this step we will do. Now think thus further let's understand the further. Now we'll traverse both lists together, right? When both are not equal, means first we will check the both. Similarly we'll do for this one also, that I have talked about this one, right? So we have to check both lengths should be there, right? Now we'll traverse both the lists together to find the intersection. How we are going to find the intersection? Let's suppose we have length A we have, right? Or not the length. Let's take the head. So we'll take a while loop and we'll say if head A not equal to head B, right? Means both are not at the same position, right? When both are not equal, or when both not intersect, right? Until they have not intersect. Yes, we can say until they have not intersect, right? Until we have not intersect, then what we should do? We'll keep moving ahead. Means head A will move to head A dot next, right? Similarly, this head B will move ahead, head B dot next, right? Means until they have not met, both heads are not met. Understood here? Let's understand again here. So both the starting till here we have understood, right? Till we have understood. So now the head is head B is at where? 6. Head A is at 4. So now we are saying if both had not met until we not reached here, this head A will move to head at 1, then it will move to 8. Similarly, it moved to 6 to 1 and 1 to 8. Like this, we are moving ahead. Next. Now we both reach at where? Both head is pointing to 8, right? So when both pointing to 8, this loop will not work. This loop will not work. So either you return head A or head B. Either you return head A or head B, means this is the intersection point. So what we will do, either both null or both points to the same node, right? We'll write the return here. How we are going to write the return here? Just return, let's suppose we'll return A, right? We'll return A, head A, right? Because both reach to here, right? So let me recap you again, right? Let me zoom out a little bit, okay? So this is a very simple approach, right? What we need to do, we'll first find the length. You know how to do how you are going to find the length of the list, right? That you can do, right? This is the first step you need to do. You have to find the length of both list. Then check the length. If both length are not same, right, it means we have to increase the head ahead. Like in this case we are increasing the head from 5 to 6, because the list B is having size 5, right, 6, and list A having length 5. So list A having length 5 and B having 6, it means we have the head B, we have to move ahead from 5 to 6, right? And so we are doing here and we are decreasing the length. Now both length are same, so these two loops will not work. We have to move ahead, right? Now we will check the head, both heads are same, right? With both heads points to the same position. Is it the intersection points? No. Then head A will move from 4 to 1, then it will move to 8. Similarly, we'll move 6 to 1 and 1 to 8, right? And each time when we are moving, we will decrease, we will move to the next one, right? We will not decrease anything. That we will do, we are moving here, right? So once we will reach both head A and B will reach to the 8, right? It means both are same, so this loop will stop and then we'll return the head, right? Because either you return head A or head B, both are meaning the same, we'll return the same answer. Okay, so I hope you understand, guys, right? Let me know in the comment box that you understood the problem statements and as well as the solution. And if you talk about the time complexity, I told you the length of A and B will be there, right? So we'll say the complexity thing that it will take time complexity. TC will be, if we will take length of head A, means first list as a M, then we'll take the N for the list 2, right? So this will be the time complexity, and you know the space complexity, right? We have not taken any extra spaces, and so the length will be like this. Thank you, guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.